Hi everybody, welcome to another video in Math 1324, section 4.2 and 4.3. I've combined these two sections together because it is a long continuous concept. So first we have a concept of the augmented matrices. So a matrix is just array, rectangular array of numbers, so we just have a table of numbers. Like this, and then we can represent a system of equation by an augmented matrix by storing coefficient and constant of a matrix. For example, for this system, we will store the coefficient of x's 1 and 4, and then for y 2 and 5. The equation we denote by a vertical line, then 3 and 6. So this is the augmented matrix for that system of equation. And I said one example. It's good enough to explain that concept. All the coefficient on the left equal sign denoted by the vertical bar, and the constant on the other side. And then of course we can say this coefficient for x is coefficient for y. Right. Now here, what we can do to a matrix. Two rows are interchanged. So let's just like two equations are interchanged. A row is multiplied by a non-zero constant. If you multiply the whole row by a constant, it is just like multiply an equation by a constant. And then a constant multipliers. Multiply one row by a constant, then add to another one. This is a little more complicated. Right, we'll get back to that. So, and let's say somehow we arrive into the matrix in this form where we have 1, 1, something, something here. This is where we have a unique solution. Now, if you rewrite the equation, let's say it 1x, 0y equal to something, 0x, 1y equal to something. So that's pretty much the solution, right? X equal to something, y equal to something. That's what this system represents. Now this we have a whole row 0, that infinitely many solutions. And if we have 0, 0 and something else, like if this equation you rewrite as, this row do rewrite as 0x plus 0y equal to something else that is not equal to 0. Now this is impossible to have. If you have no x, you have no y combined, you should not have anything. And so I said we get back to this. Now we go to the reduced row echelon form, RREF. So each row consists of, so this is the rule here, each row consisting entirely row of 0 will be below any row with at least one non-zero entry. So if we have 0, row of 0 at the bottom, so that the first one say row of 0 at the bottom. So row consists entirely of 0 is below, so that below at the bottom. The first non-zero entry is called the pivot. This is very important. The first non-zero entry is called the leading one or the pivot entry. So it has to be 1. It cannot be any other number. It has to be 1. That's called the leading one or the pivot entry. After the 1, you have everything after that is going to be 0. Yeah. Leading one is row on the right, and then you stack them in an echelon form, which is a step. Right. So what do we have here? Just go to an example. We'll say, so first rule is row of 0 at the end. At the bottom. Like this. Next, each row we're starting from a 1, and after that everything else 0. So each row there's only we start with a 1. Of course after that can be anything else, but we know this start with a 1 for each row, and after that whatever the 1 is, they have to align that in the step. So step on me going down to the right, down to the right. So all the 1 have to align like that in this direction, going down to the right, down to the right. That means echelon, which is the steps. So the 1 must align on the steps, and after that the 1 is the only non-zero entry. So if we have 1, everything else on that column has to be 0. Once again, if you have 1 on any column, everything else must be 0. If you don't have the 1, everything else could be anything. I mean the 1 meaning that the leading 1 or the pivot entry, right? And then if there's something else, if they don't have 0, we just have that blank. So the rule here is very clear. Row of 0 at the bottom, start with the leading 1. And the next one kind of difficult. The leading 1 must align in the steps, going down to the right, down to the right. And then so leading 1, leading 1s align in the step, in the steps like a stair going down to the right. And then for the 1 leading 1 is the only non-zero entry in each column. Each column with leading 1 has 0 everywhere else. So once again, each row start with a 1, and the 1 are in steps. I mean down to the right, down to the right. And then this entry doesn't have the 1, it could be anything. Actually, in fact, if this happened to be a 5 here, it's still fine, because in that there's this column, there's no pivot, no leading 1, so it could be anything. This of course can be also be anything too. This have to be 0 because the 1 here, the first on each row, the first one has to be a 1, so you cannot have something else here. This cannot be 5. It have to be 0 because the 1s there, everything before the 1 have to be 0. Right, now this is the procedures. Working by column from left to right. We obtain the 1 first, and then we obtain the 0. Working by column from left to right. So by column from left to right. So first, let's write this matrix as a system. On this one, of course, I can show step on the calculators too, but that is too tedious and complicated. We're not going to do that. Just do everything by hand, and of course we can use a calculator to check our work. Right, let's go. Now from this, we write this in the augmented matrix. 2x, 1y, 1z, and then 5. I draw a line there. 2, 1, 1, and 5. 1x, 0y, 1z equal to 3. 3x, 2y, 2z equal to 9. So that is what we start with. Have to be very careful. If we make one mistake, it will be a compound and it get out of hand quickly. Have to be very careful. Right, now, okay, so working from column, from left to right, and from each column, get the 1, and then we get the 0. So now we check this, we need to have the 1 here from the first column we have the 1, so 1 have to be here, so this need to be 1. To do that, there's two ways. We can divide the whole row by 2, or we can swap row 1 and row 2. So the notation now we write in like here, row 1 and row 2 interchange. So in that case, we will have this 1 0 1 and 3 2 1 1 and 5 3 2 2 and 9. So now we have the 1. For each column we need to get the 1 where we want. So ideally we have 1 here, 1 here, and 1 there, but we don't worry about that one yet. Work from column from left to right. So we have the 1 here. If we have the 1 here, the next one we turn everything in that column to 0. So get the 1 first and then get the 0. We'll turn this to 0. Well, to turn in 0 is difficult. We cannot just say we divide or swap row or anything. To eliminate to 0, there's only one way to do that. It's elimination. You remember equation, like we multiply one equation by something to eliminate. So if you want to eliminate this, we can multiply this by 2. In that case, that 1 times 2 is going to be 2. But we want that to eliminate this, so multiply by opposite to that, opposite to the number we evaluate. We try to eliminate. So multiply by -2. The scratch work I write in green here. So that gives us -2, 0, -2, and -6. Row 2 here, I copy, stay the same, 2, 1, 1, and 5. Now we just add them. That will be 0, 1, -1, and -1. Right, and this is going to be the new row 2. New row 2, so row 1 and 3 will stay the same. Now the row 2, I'm going to write that. Row 3 stay the same. Now we check. We have the 1 here. Good. That next we have 0, which is good. Now this needs to be turned to 0. And to do the by the way, this process can be summarized as this. We multiply -2 to row 1, the row 1 that have the pivot. So and then we add and replace to row 2. Yeah, so add to row 2, replace to row 2. So that summarized into this process. So now we're trying to eliminate this. So whenever we eliminate, what we use is the pivot, the one that has the 1. We use that to eliminate. And if we want to multiply something to eliminate the 3, we multiply 1 to 3. So that gives us 3, but use opposite to that. So whatever number to eliminate, we use opposite. Let's say if we want to eliminate 3, we're going to use -3. Multiply by the row that has the pivot. So that -3, 0, -3, and -9. And then row 3. Combine them, that gives us what? 0, 2, -1, and 0. That will be the new row 3. And to summarize this process, we say we take -3, we multiply to the row that have the pivot, which is row 1. And then we add and replace to row 3. Right. I will write row 3 here. Then row 3. Now let's check. So on the first column, we're working by column, right? From left to right. So the first column we have 1, the pivot 1, everything else 0, which is good. So the first column is done. Now we go to second column. For the second column, we could not possibly get the 1 here because the 1 have to align in steps. So I have to go down to the right. So the 1 has to be here, which is good. We already have the 1. If we don't have it, we have to divide by something or we swap the rows. So those are options. So we have the 1 there. What needs to be done is this have to be to 0. So again, if we want to eliminate something, we base on the row that has the pivot. Now this row has the pivot. So we multiply by opposite to that. That gives us 0, -2, +2, and +2. Row 3 stay the same. But then we add them. So that gives us 0, 1, and 2. That will be the new row 3. By the way, we also have this to 0, which is what we want. So we're not going to do anything there. Right, to summarize this process, we use -2 to the rows that have the pivot now. And then add and replace row 3. So that we have 1, 0, 1, and 3, 0, 1, -1, and -1. 0, 0, 1, and 2. Right. Now let's check. First column, the 1 where we want, then 0, 0. Good. Now next column, the 1 aligns to step, so that's good. It's going down to the right. We have 0 everywhere else, which is good. So we're done the second column. Now we go to the third column. Third column, the pivot now has to be here, or down to the right, so it has to be here. So which is good. We have the 1 already. Now just this needs to be to 0, and this needs to be 0. So let's turn this to 0 first. Now remember, whenever we try to eliminate this to 0, eliminate anything to 0, we base on the row that have the pivot. This row now has the pivot. We use opposite to that. So multiply by -1. That gives us 0, 0, -1, -2. And then this will stay the same. 1, 0, 1, 3. And now when we add them, 1, 0, 0, and 1. Now this, we try to eliminate this, so if we replace this into that, this will go to 0. This will be the new row 1. One, 0, 0, 1, 0, 1, -1, -1, 0, 0, 1, and 2. Okay, so this is good. This is good. The last step is this to 0. Now the pivot for this column is going to be here. So now you know why we call that pivot. Everything will spin off of that. We just use opposite to this, so we just multiply by 1. I forgot to write what is the math there, so we multiply -1 on the last one to row 3, add and replace to row 1. Right. So now we just have that 1, and now we have 0, 0, 1, and 2. And now we try to eliminate this. So 0, 1, 0, 1. That would be new row 2. Okay. So that process is captured as you just want, so we don't really need that, but it's not wrong to write it. And the pivot is row 3. We add and replace to row 2. So that gives us 1, 0, 0, and 1. 0, 1, 0, and 1. And then 0, 0, 1, and 2. So we check that we have 1 at the pivot, and then 0 everywhere else, the 1, and then everywhere else, 1, everywhere else. So we pretty much done. So when we're done, we say it. Remember, the first column is for x coefficient, so we say 1x equal to 1, 1y equal to 1, and 1z equal to 2. So that is solving system equation within the Gauss-Jordan elimination or reduce row echelon form. Actually, the calculator can just do all of that in one step. So to see the second matrix. By the way, your calculator might look differently if second matrix, and we can go reduce to echelon form, and then alpha zoom. We have the matrix of 3 row, 4 column, and then OK. So I'm going to put the number 2. Do not hit enter in this process. Just use this arrow. 2, 2, 1, 1. Next, 5, 1, 1, 3, 3, 2, 2, 9. Right. So reduce to echelon form. This is called the reduce to echelon form. So that's the calculator do exactly that, and just give us the result. Right. I still want to. You still need to know how to go from step to step, though. So that's why we have this. Right. Now we have this. Now we're going to do this again. The same process again. So we start with the metric matrix 3, -4, 4 equal to 7, 1, -1, -2, and 2, 2, -3, 6, and 5. Right, so let's check. This need to be 1. So we can divide everything by 3, or we just swap rows. So this case just swap row. So we say row 1 and row 2 swap. That case the 1 will be there. So let's check. We have the 1. Now just need to turn this to 0. This needs to be to 0 as well, but one step at a time. So to eliminate this, what we use is opposite to that number. So see why now we need the 1. After we have the 1, eliminate will be a lot easier. So that's why we prefer to have the 1. So multiply by -3. That gives us -3, +3, +6, and -6. 3, -4, 4, and 7. There's 0, -1, 10, and 1. That will be new row 2. See, perhaps there's enough space to do this. Hopefully. So, I will summarize this process here. -3 times row 1, add and replace to row 2. So we do that process, we're going to have the next matrix. That's the new row 2, but row 1 and 3 will stay the same. Row 3. Right, let's check. We have the 1, now the 0. Now we can turn to this to 0. Right, to eliminate this, we use opposite of that number we try to eliminate. Multiply to the pivot, the row that has the pivot. -2, +2, +4, and -4. And now we try to eliminate this, so that will be the same. Add them 0, -1, 10, and 1. Interesting, that looks familiar. That will be new row 3. So what we did was -2 row 1 plus row 3 store to row 3. row 2. Now new row 3. So first column, check, check, check. Now next one, of course we say this the same, of course that have some implication, but we just do step by step. We need this to be a pivot. The pivot need to be there because it goes down to the right, so that need to be 1. We cannot swap any row, so in this case we done a new step here. We just multiply everything by -1, or we divide everything by -1, doesn't matter. But if you multiply by -1, you have 0, 1, 10 and 1. That will be the new row 2. So what we did was negative row 2 to row 2, and so we write this as 1, -1, -2 and 2, 0, 1, 10 and 1. Row 3. When we multiply by -1, right? -1 times -1 is 1, so that gives us -10 and -1. I forgot that. Right. Right, so check. That's good, good, good. Now the pivot here is good. We just need this to be 0. We need this to be 0. Of course, this we can turn to 0 anytime, but let's just focus on this to 0. Of course, you can turn that to 0 too after it. I just want to do this first, and then we turn that to 0. Right. The pivot is here, so we have to multiply by something opposite to this. So just 1. That gives us 0, 1, -10 and -1. Row 3 will stay the same. We'll add them 0, 0, 0 and 0. That is going to be the new row 3. So what we did was row 2 plus row 3 to row 3. Of course we multiply by 1, but multiply by 1 we really don't need to write it. Multiply by 1. So we just say row 2 plus row 3 to row 3. And with that we have 1, -1, -2 and 2, 0, 1, -10 and -1, 0, 0, 0 and 0. So this we have a whole row of 0 like this, and because there's something else there. If you have the whole 0 and there's a 1, there's still no solution. But for this context, this one we have the pivot here, the pivot there, and then the whole row of 0. So this is infinitely many solutions. Now, we do need to write the solution. Once again, it has infinitely many solutions doesn't mean anything can be solution. So actually we have to work from that again. Remember, we haven't done to reduce this to a reduced row echelon form yet. So we still need to turn this into a 0. So for that, the pivot here will stay the same. because it is opposite to that, so just 1. So 0, 1, -10, and -1. Let's just copy that row. Step 1, 0, -12, and 1. Right, that would be new row 3. New row 1, sorry. So row 2 plus row 1 to row 1. Right, just write that again. We have new row 1 here. Row 2. Right, so that's what we have. Now, so check the pivots. We have here and here. Now, the last problem, when we have the pivots, that's where we write the solution. Like this, we have x column, y column, and z column. So x is going to be 1, y, where the pivots are 1, and z 2. So that the pivot on x, y, and z. Now we only have the pivot for x and y. So let's write the equation out first. 1x minus 12 z equal to 1. 1y minus 10z equal to minus 1. Now we have x and y, pivot from x and y, so we can solve for it. So we can x is equal to 1 minus 12z, and then y equal to minus 1 plus 12z, sorry, plus 12z on both sides, and plus 10z on both sides. And then we have no pivot for z. So here we say x is in term of z, y equal to term of z, and z is, there's no restriction here, so we say z is arbitrary. So we write the solution as x equal to 1 plus 12z, or y equal to minus 1 plus 10z, and z is arbitrary. That's how we write the solution. Infinitely solution, yes, but it doesn't mean anything. It can be anything. It can have certain restriction to it, and it x, y, z depend on each other, like this set relation. Right. Otherwise, I want to check with the calculator when possible. So second matrix, go to reduce to echelon form, and then we have, I'm going to type this in 3. If we have the minus, a negative, use this negative sign, don't use subtract. -4. Don't hit enter. Just go to the next number. Right, so we have the same thing, and of course the result is here. Right, next, let's look at this example again. Not again. This we're just going to use the calculator here. Right. By the way, if you don't have this calculator, please just go to the link in the description. I put the link in the description where you can just have the online calculator that do the same thing here. Right. So let me just write this as the romantic matrix. And we do reduce to echelon form, and we have that. Right. So again, we have the pivot on the x, we have the pivot on the y, but no for z. So in that case, z could be arbitrary. Now let's write the equation for this. 1x minus z equal to 2, 1y minus 2z equal to negative 3, and z is arbitrary. So in that case, we have we step further. We can solve for z. We can say, so everything in terms of z. So for the pivot x and y, we can solve for x and y. So we have the solution as x equal to 2 plus z, y equal to negative 3 plus 2z, and z is arbitrary. Right, so that's how we have infinitely many solutions. Right, last one. This is to set no solution. So what do we do when we have no solution? Let's just write the romantic matrix first. Once again, if you don't have this calculator, we go down to the description. There should be a link. One, negative 3, negative 17, negative 59. Right. Second matrix. If you have a calculator or your calculator cannot do this, just go down to the description and find that link. Right. So if we do reduce to echelon form, we have 1, 0, -2, 0, 0, 1, 5, 0, 0, 0, 0, and 1. If we check the pivots, it will be here, here, and actually the pivot is here. We have x and y, but the 1 is here. Right. So why is this no solution? Well, the last one, if we have 0x plus 0y plus 0z and that equal to 1, that is impossible. If we have nothing equal to something, so that's not possible. So that is where we have no solution. So to recap, in this section we try to get into reduce to echelon form, where we have 1 in the steps and 0 everywhere else. If we have a row of 0 like this at the end, row like that at the end, and the pivot, we don't have the pivot on the last column, then that infinitely many solution. If we have the row of 0 and no pivot in the last column, if there's the pivot in the last column like this, that's no solution. 0, whole row 0, no pivot in the last column, infinitely many solution, and we can write solution based on the missing pivots. Other than that, if we have the pivot everywhere on the diagonal line like this, then there is a unique solution. And with that, we finish these two sections, 4.2 and 4.3. Thank you for watching, and see you in another video in Math 1324.